Hi, Mr. Green here. I'm going to be taking you through this. This is the second lesson of the physics topic Atoms and Radiation. Title: Discover the Nucleus, and your learning objective today is to know why the atomic model has changed over time. If you could pause the video and write that down as your title. Okay, your retrieval practice today, 5 questions on there. If you could pause the video whilst you attempt each question and restart the video when you like the answers. Okay, if you could pause the video now. Okay, question 1, the mass number of an element. The mass number of an element will tell you the protons and neutrons present in the centre of the nucleus, okay? What does the atomic mass number tell you? Well, the atomic mass number is different from the mass number. It just tells you the number of protons in the nucleus. So remember, if you take away the atomic mass number from the mass number, it tells you the number of protons. Why do atoms have no overall charge? Well, we know protons are positively charged. We know electrons are negatively charged. To cancel each other out, we have to have the number of protons and electrons as equal. So 5 protons, 5 electrons, overall, no overall charge. Question 4, what's ionization? Ionization is when an atom becomes an ion due to an electron being knocked off the electron shell. Again, radioactive materials can do this. They provide enough energy to knock that electron off the outer shell, and that then unbalances the atom, making it an ion, making it a charged particle. And finally, question 5, what is an isotope? It's an atom with the same number of protons but different numbers of neutrons. Okay, our learning outcomes for today. Learning outcome number 1 is explain why the atomic model has changed over time. And our second one is to compare and contrast the plum pudding model of the atom with the nuclear model of the atom. Okay, so starting off, our first question. Is the Earth round or flat? You'll have your own opinions on that, but how do you know the Earth is round? So think about that for a second. Pause the video while you think about it. Okay, you come to your conclusion. Who told you whether the Earth was round or flat? And is it important who told you whether the Earth was round or flat? What evidence do you have to support what you state? If you're stating the Earth is round, you'll need evidence to support that theory. And has it been proved? Have other scientists proved this? Have they published their findings? Have they showed it and convinced other people? This is what science basically is. It is proposing a hypothesis, producing evidence to prove that, and ensuring that evidence stays and other people don't disprove that. So how science works is a general process, and here's the process that all scientific theories follow. First off, we ask a question. So that question could be, what shape is the Earth? That question could be, what shape are particles? That question could be anything you want explaining. The second part you would do is formulate a hypothesis. That's an idea that can be tested. So for example, we would state that the Earth is round. That's our hypothesis. Third, we would perform an experiment. So we'd do an experiment where certain parameters would change, certain parameters would be measured, and that would either prove or disprove our hypothesis. From that, we would collect the data, and then from the data, we would draw a conclusion, see what the data proves, see what the data leads us towards. Finally, and most important, we need to see if others can replicate what our findings were. So we would publish our findings, we would show everyone our findings, show them the experiment we've done, and allow them to do the experiment themselves and see if they come up with the same answers as we do. Why do you think it's important that my results and conclusion need to be replicated by other scientists elsewhere? Pause the video while you answer that one. Okay, it's important that it's replicated by other scientists elsewhere so that we know the theory stands up, that it is this one thing that affects another thing. And it's not something I've made up, it's not something that was a one-off, it's not something that was based on where I was at the time, it's something that will happen everywhere all the time, and so it can be taken as a scientific law. Any other scientific ideas that have changed that you can think of? If you do a bit of research, you'll find that almost all scientific ideas have changed over time, and the reason they change is more evidence is found. So on to today's lesson, the atomic model. Now, before we discovered electrons, atoms were thought to be really tiny spheres that couldn't be divided up. This theory came from a scientist called John Dalton, and so it became known as Dalton's atomic model. This is what he stated: all matter is made of atoms. Atoms cannot be broken down into anything simpler, and all the atoms of a particular element are identical to each other, and different from the atoms of other elements. Now, the discovery of the electron had to lead us to a new model. Again, tiny spheres that couldn't be divided. This electron threw a bit of a spanner in the works there. That's what Dalton thought, so they came up with a new theory, and this new theory was called the plum pudding theory. Now, the scientists thought that the atom was like what's called a plum pudding, as you can see on the picture there. What we thought was the cake itself, the dough of the cake, was positively charged matter, so the mass of it was positively charged, and evenly spread throughout that positively charged dough were electrons that were buried inside. So the pudding itself was the positively charged matter, and the electrons are the plums you can see just dotted through there. So as we can see, the plum pudding model suggested the atom is a big ball of positive charge with negative electrons embedded in it. And we thought that for quite a while. We needed, again, some experiments that would prove that that's the case. So, we did an experiment with these atoms. We stated that the plum pudding model suggested the atom is a ball of positive charge with negative electrons embedded in it. The positive charge was cancelled out by the negative charge, so the positive charge of the dough overall was cancelled out by the negative charge of the electron, so overall it was neutral. If we fired alpha particles at the plum pudding model atom, what would we expect to happen? Remember, alpha particles are positively charged. Now, based on the plum pudding model, we would expect that the alpha particles would all bounce back from the atom. Because they're positively charged, they would encounter positively charged mass in the atom. So, no space in the atom at all taken up by this positively charged dough with negative charges dotted throughout it. What would happen is, alpha particles in and bounce straight back. Alpha particles in and bounce straight back. Okay, let's have a bit of a progress check, see how we are so far on this. So, 5 questions. Pause your video, please, and answer these 5 questions. Unpause when you'd like the answers. Okay, question 1. What's a hypothesis? A hypothesis is an idea that can be tested by gathering evidence. Number 2, why is it important that results from an experiment can be replicated so we can be sure that we can trust the new theory is correct? It's going to hold water everywhere. What happens to a theory if new evidence is discovered that proves it wrong? The theory changes. We can't ignore evidence. So evidence is what draws us towards these theories and what will change the shape of theories. What was John Dalton's theory? His theory was atoms were tiny spheres that could not be divided. And the plum pudding model of the atom is that the atom is a ball of positive charge with negative electrons embedded in it. Okay, the experiment we talked about previously was done. It was performed by a fellow called Ernest Rutherford at Manchester University. He took a very, very thin piece of gold foil, almost 1 atom thick, and he fired alpha particles which are positively charged at it. Now, if we look at the experiment, we can see what's happening. And it's not what we expected. We expected all those alpha particles to be deflected straight back. Most particles are going straight through. And most particles are undeflected. They're just passing straight through there. Some particles are being deflected and they're curving, so they're passing through and curving round there. And some particles are being deflected more than 90%, so they are bouncing back. The plum pudding model would not support this taking place. It wouldn't support this answer. So we need to think, what's happening in this case? So most of the alpha particles passing straight through. This tells us most of the atom is empty space. Most of it is made up of absolutely nothing at all. Number of alpha particles deflected per minute decreased as the angle of deflection increased, and about 1 in 10,000 alpha particles were deflected by more than 90 degrees. This tells us because alpha particles are positively charged, in order to repel, they must have encountered a really strong positive charge. Now, because not many of them did, that charge must be very, very concentrated. This proves the atom's got a concentrated positive nucleus, so a very, very small positive nucleus that can deflect that. From there, we had a scientist called Niels Bohr. Niels Bohr proposed the idea that electrons in an atom will orbit the nucleus at specific distances and specific energy levels. Electrons can also change to another energy level by absorbing or emitting electromagnetic radiation. So those electrons are on a fixed path around there. If they get more or less energy, they'll change how far the path is. Do we think absorbing electromagnetic radiation will cause electrons to move to a higher energy level or a lower energy level? Think about that for a second. Absorption and emission of electromagnetic radiation causes electrons to move between different energy levels. So absorbing electromagnetic radiation gives the electron more energy, it moves to a higher level. When it emits energy, it moves to a lower level. Use of more alpha scattering experiments showed the hydrogen nucleus has got the least amount of charge, and any nucleus consists of a small bunch of particles, each with an equal positive charge. But we knew that the mass of every nucleus other than hydrogen was bigger than the total mass of the protons. So what's our explanation for that? It's that there must be another type of small particle with no charge in the nucleus that's about the same mass as the protons. And this particle is what we call the neutron. It's in every nucleus apart from hydrogen. Really, really difficult, and was the last one to be discovered because it's got no charge, so it barely interacts with anything that we can give it. Okay, further progress check. 5 questions there. If you could pause the video and answer those 5 questions. Thank you. Okay, question 1. If the plum pudding theory was true, what should happen to alpha particles that encounter it? They should all bounce back. They should all hit there and bounce straight back. It's made of it's got a huge mass, and that mass is positive. It's got electrons dotted around it that are negative, but it should all bounce back. Most particles pass through, so what does that tell us about the atom? It tells us that the atom is mainly empty space. It's mainly made of nothing. Small number of particles bounce straight back, and what does that tell us? Well, that tells us that because alpha particles are positively charged, in order to repel, they must have encountered a very strong positive charge. Because not many of them did, this charge must be very, very concentrated, very small. So this proves the atom contains a small, concentrated positive nucleus. What did Bohr propose? Well, Bohr proposed that electrons orbited the positive nucleus. And what was the last part of the atom to be discovered? And why do we think this was? The last part was the neutrons. They're really hard to discover because they've got no charge, so they're not affected by many other things. Okay, really quick quiz for us here. You need to have A, B or C as your answer. So pause the video and give your answers for 1, 2, 3, 4 as A, B or C. Okay, question 1. Who said that atoms were small, indivisible spheres? Was that Alan Partridge, B, Gruff Rhys, or C, John Dalton? Correct answer C, that was John Dalton. Question 2. What was the first model of the atom proposed? Was it A, the cherry flan, B, the plum pudding, or C, the grape cake? Correct answer there is the plum pudding model. Question 3. What were alpha particles fired at in Rutherford's experiment? Were they fired at A, gold leaf, B, silver petals, or C, bronze foil? They were fired at gold leaf, really, really thin gold leaf, 1 atom thick. And what's the order of discovery of the subatomic particles? Was it electrons, then protons, then neutrons? Protons first, then neutrons, then electrons? Or protons, electrons, then neutrons? Order of discovery was protons, then electrons, then neutrons. Finally, a 6-mark exam question for us here. Scientists sometimes replace one scientific model with a different model. For example, in the early 20th century, the plum pudding model of the atom was replaced by the nuclear model. Explain what led to the plum pudding of the model atom being replaced by the nuclear model of the atom. It's a 6-mark question. Pause the video, give yourself a few minutes to answer that full essay style. Once you unpause, we'll go through the full essay answer. Okay. From the mark scheme on here, we can see there's 3 levels of answers. Your best answer, your level 3 answer worth 5 to 6 marks, is a detailed explanation, clear knowledge shown, and links between relevant points. These are the points you needed to make. Number 1, there was an alpha particle scattering experiment where alpha particles were fired at gold foil. The results of this experiment were A, most of the alpha particles passed straight through, which means most of the atom's empty space. B, a few particles deflected through large angles, which means the mass is concentrated at the centre of the atom and is positively charged. The plum pudding model had the mass spread throughout the atom, and the plum pudding model had the charge spread throughout the atom. So the model of the plum pudding model did not correlate with the evidence we got from data. So the data we received from our experiment did not marry up with the plum pudding model. So as a result, we changed that. Thanks very much. I hope you found that video useful and hope to see you soon.